Good evening again. So please put your attendance in the chat box, all of you. Okay, so I can see all of you have put the attendance. Who's remaining? किसका attendance लिखना बाकी है? 1, 2, 3, 4. Okay, fine. Just allow me a minute. Just allow me a students. I'll be right back. Okay, sorry for the small interruption. So I believe we have finished the chapter gravitation, which was 10th chapter. And today we are going to start a new chapter, that is 11th chapter, work and energy. Okay, so let's see what we are going to learn. In the previous few chapters, we have talked about ways of describing the motion of objects, the cause of motion and gravitation. Another concept that helps us understand and interpret many natural phenomena is work. Closely related to work are energy and power. In this chapter, we shall study these concepts. All living beings need food. Living beings have to perform several basic activities to survive. We call such activities as life processes. The energy for these processes come from the food that we eat. Right? So we need energy for other activities like playing, singing, reading, writing, thinking, jumping, cycling, and running. And there are many more activities also. So activities that are strenuous require more energy. Strenuous means hard activities. Okay, I have completed this chapter. What do you mean by I have completed this chapter? That means, is this chapter covered in your class or in school? All of you, please reply. Is this chapter has been taken in class? Has this chapter been taken in class? All of you, please confirm. No, here. Okay, not here, right? Yes, in the school. I believe this chapter has not been taught in this class, essay online class, correct? Okay, so even if you have completed this chapter in your school, it is going to be very easy for you to understand the concepts, right? It is kind of a revision for you, isn't it? So it is good revision. Okay, so let's continue. So I'm asking this because I'm taking your physics part only, and the rest of the part will be taken by two other teachers. Okay, so that's why I thought some other teacher might have taken this. So that's why I was confused. But thanks for confirming that this chapter has not been taken in our class. So we can continue with the class. No problem. So animals too get engaged in activities. For example, they may jump and run. They have to flight, move away from the enemies, find food, and find a safe place to live. Also, we engage. Also, we engage some animals to lift weights, carry loads, pull carts, and plow fields. All such activities require energy. Think of machines. So list the machines that you have come across. What do they need for their working? So can all of you just put a name of machine? कोई भी एक machine का आप लिख सकते हैं नाम. Put a name of any machine. 4 machines. आप चार लोग हैं ना, तो 4 machines का नाम आप रख सकते हैं, लिख सकते हैं. Combine. What is that? Which machine is that combined? Okay, all of you must have seen motorcycle. This is a machine, isn't it? Then what are other machines? Can you remember? Can you, for both harvesting and winnowing? Steam machine. Okay. Steam engine, sorry. Yeah. So the point here is, so you have seen machines, right? And they also consume their food, which is, that might be fuel, or that might be gas, or that might be some other source of energy, right? So they also need something that can power them or that can give them energy, and those machines can work, right? So why do living beings and machines need energy? क्यों लगती है हमें एनर्जी? व्हाई डू वी नीड एनर्जी? टू डू सम, टू परफॉर्म सम वर्क, कुछ करने के लिए, वर्क करने के लिए वी नीड, we as well as animals as well as machines need some energy, isn't it? So what is work? So our chapter's name is work and energy. So there's a difference in the way we use the term work in day-to-day life and the way we use it in science. To make this point clear, let us discuss few examples. ठीक है? तो जब हम वर्क की बात करते हैं in our day to day life, we talk in some other direction, or we talk in some other context, right? But when we talk about work in scientific manner or in scientific terms, so it has some other meaning. Okay, so these two terms may collide at some point, but these are not exactly the same terms. Which terms? The work, the word work that we use in day-to-day life, and the concept work that is used in scientific field. Okay, तो किस तरीके से different है, that we'll learn. So see, not much work in spite of working hard. Now Kamli is preparing for examinations. She spends a lot of time in studies. She reads books, draws diagrams, organizes her thoughts, collects question papers, attends classes, discusses problems with her friends, and perform experiments. So she expends a lot of energy on these activities. In common parlance, she is working hard. All this hard work may involve very little work if we go by the scientific definition of work. Okay, now let us suppose you have read a book of 200 pages in a day. Let us suppose, okay, you have read a book of 200 pages in a day. So that is too much of work, isn't it? You are working too hard. Can we say that? Isn't it? But in scientific terms, this may not be too much of work. तो किस तरीके से विल लर्न दैट, कि मैं तो दिन भर पढ़ रहा हूं या फिर पढ़ रही हूं, एंड द साइंटिफिक टर्म सेज आई हैवंट वर्कड इनफ. कैसे हुआ? राइट, सो वी नीड टू अंडरस्टैंड द डिफरेंस बिटवीन the concept work that we use in day-to-day life, or usually or generally or casually, and the term work that we use in scientific terms. ठीक है? तो कैसे इसका डिफरेंस पता करें? Let's move ahead with the chapter. You are working hard to push a rock. Let us say the rock does not move despite all the effort. You get completely exhausted. However, you have not done any work on the rock as there is no displacement of the rock. ठीक है, एक बहुत बड़ा पत्थर है, बहुत बड़ी चट्टान है. Okay, and you are putting all your efforts into it to like push it. या फिर आप टीम बना के उसको पुश कर रहे हो, राइट? एंड ऑल ऑफ यू गेट एग्जॉस्टेड, आप थक जाते हो, बट वो पत्थर जरा सा भी नहीं हिलता है. सो हैव यू वर्कड और नॉट? आपने काम किया या फिर नहीं किया है? When you are pushing the stone or you are pushing the rock, then you are working, isn't it? When we talk in casual terms. But in scientific terms, your work done is zero. Okay? Can you do you agree with me? Please keep responding in the chat box, students. समझ में आ रहा है मैं जो बोल रहा हूँ? Okay, thank you. Thank you for confirmation. Okay, let's move forward. You climb up the steps of staircase and reach the second floor of a building just to see landscape from there. You may even climb up a tree. If we apply the scientific definition, these activities involve a lot of work. In day-to-day life, we consider any useful physical or mental labor as work. मतलब हम कोई भी physical activity करें या फिर mental activity करें, mental activity not in the sense of पागलपंती. Mental activity means the work that we do by our brain, मतलब जो हमारा brain का use करके हम जो work करते हैं, that is mental labor. So activities like playing in the field, that is physical, talking with friends, this is also kind of physical. So humming a tune, watching a movie. Now watching a movie is work or not? Watching a movie is a work or not? And which type of work it is? In general terms, not scientific terms. Watching a movie is a work or not? No, it's not a work. Okay, मैं scientific term की बात नहीं कर रहा. बाकी लोग, what do you think? मूवी वॉच करने में हमें वर्क करना पड़ता है या फिर नहीं करना पड़ता है? Okay, let me give you an example. Okay, so uh, I I hope your name is Aidur, right? Or okay, sorry, Safur. Yeah. So let's discuss more about this. आप एक मूवी देख रहे हो, ठीक है? एंड बहुत ही बोरिंग मूवी है, लेट अस सपोज. ना उसमें कुछ फाइट है, ना सॉन्ग्स है, ना कॉमेडी, कुछ भी नहीं है. लाइक इट्स वेरी बोरिंग मूवी. और आपको बीच में ही नींद लग जाती है. ओके, यू फेल asleep. ठीक है. तो जब एट द एंड ऑफ मूवी एंड हो जाती है और आपको पूछते हैं व्हाट इज स्टोरी स्टोरी ऑफ दिस मूवी, बताओ. क्या बता पाओगे? आप बता पाओगे उस मूवी की स्टोरी? आप आधी मूवी में सो रहे थे. नो, यू विल नॉट बी एबल टू टेल द स्टोरी. व्हाई? बिकॉज यू आर नॉट अटेंटिव. लेकिन अभी एक बहुत अच्छी मूवी है एंड यू आर लाइक फुल अवेक टिल एंड ऑफ द मूवी. मूवी एंड होने तक आप देख रहे हो उसे. सो क्या तब आप स्टोरी बता पाओगे? Yes, you will definitely be able to tell the story because at that time your brain, your ears and your eyes were at work. वो काम कर रहे थे. Eyes देख रही थी. Ears जो है वो सुन रहे थे. And your brain was processing the story, isn't it? मतलब you were working but mentally. मतलब आप mental work कर रहे थे. Correct? Work ही कर रहे थे in general terms. So that was mental work. So watching a movie is also a work. Attending a function are sometimes not considered to be work. What constitutes work depends on the way we define. We use and define the term work differently in science. तो साइंटिफिक टर्म्स में ये चीजें भले ही वर्क ना हो, right, but still they can be considered as work in general terms. To understand this, let us do the following activity. We have discussed in the above paragraph a number of activities which we normally consider to be work in day-to-day life. For each of these activities, ask the following questions and answer them. What is work being done on? तो अगर हम मूवी की बात करें तो किस चीज पे वर्क हो रहा है? नथिंग. कुछ किसी भी चीज पे वर्क नहीं हो रहा, बिकॉज वी आर सिटिंग and there is some picture playing in front of us. ऐसा कोई ऑब्जेक्ट नहीं है. So what is happening to the object? Object है object. Actually, there is a screen, but nothing is happening to that object. जो फिल्म चल रही है उसके अलावा. Who, what is done? Who is doing the work? कौन कर रहा है work? Are you working, or the speakers are working, or the projector is working? Who is working? It is not clear. So what is scientific conception of work? To understand the work, we view work and define work from the point of view of science. Let us consider some situations. Push a pebble lying on the surface. The pebble moves through a distance. You exerted a force on the pebble and the pebble got displaced. In this situation, work is done. ठीक है. Pebble यानी कि एक छोटा सा पत्थर होता है ना, कंकड़. So if we push it and it gets displaced, That means some work is done. A girl pulls a trolley, and the trolley moves through a distance. The girl has exerted force on the trolley and it has displaced. In this case, also the work is done. Lift a book through a height. To do this, you must apply a force. The book rises up. There is force applied on the book, and the book has moved. Hence, the work is done. ठीक है, तो अभी आपको समझ में आ रहा होगा कि what is what is meaning of work in scientific terms. Right. A closer look at the above situations reveal that two conditions need to be satisfied for work to be done. अगर work करना है in scientific terms, so there are two conditions. Uh, first of them is a force should act on an object. कुछ तो force act होना चाहिए उस object पे, and the object must be displaced. उसकी displacement होनी चाहिए. Okay. So if any one of the above conditions does not exist, work is not done. This is the way we view work in science. जब हम scientific terms की बात करते हैं, work को इस तरीके से देखा जाता है या फिर इस तरीके से डिफाइन किया जाता है. So a bullock is pulling a cart. The cart moves. There is a force on the cart and the cart moved. Do you think that the work is done in this situation? क्या लगता है आपको? वर्क हो रहा है इस सिचुएशन में. जो बैल है, आपने बैलगाड़ी सबने देखी होगी आई बिलीव, राइट. सामने दो या फिर मोस्टली मोस्टली दो बैल होते हैं या फिर एक बैल भी होता है किसी किसी सिचुएशन में. तो व्हेन अ बुल और बुलक पुल्स द कार्ट, उस गाड़ी की डिस्प्लेसमेंट होती है. there is force that is applied by the bullock on this cart, right? So in this case we can say that the work is being done on the cart. So think of some situations from your daily life involving work. List them, discuss with your friends whether the work is being done in situations. Try to reason out your response. If work is done, which force is acting on the object? What is the object on which the work is done? What happens to the object on which work is done? So आप सब लोग एक सिचुएशन मुझे बताएंगे जिसमें कि यू डू एक्चुअल वर्क इन साइंटिफिक टर्म्स. मतलब साइंटिफिक टर्म्स में आप कुछ वर्क करते हो, तो उस टाइप की सिचुएशन आप मुझे बताएंगे. एवरीबॉडी विल टेल वन सिचुएशन एंड इट हैज टू बी डिफरेंट. बताइए, ऑल ऑफ यू प्लीज टेल मी द सिचुएशन वेयर यू आर वर्किंग और यू आर पुटिंग सम वर्क. When we kick the ball, okay, nice. Throwing stone, hence the force act on objects various places. Okay. Throwing the stone. The last one is remaining. Who's that? Who is not answered? Sharanjit Kaur. Sharanjit, can you give me an example of work done? Are you there? Okay. Sharanjit is not there, I guess. Okay, you're there. So can you give me an example of work done? Any simple example. अगर आपको समझ में आया है कि what is exactly work means in scientific terms, so you can easily give me an example. There are two conditions for work to be done in scientific terms, right? The first one is there has to be a force involved. तो subject पे force हमें apply करना पड़ेगा. And the second condition is the object must be displaced, right? So Sharanjit, do you play cricket? You play cricket? Okay, Safiur doesn't play, Sharanjit plays. Are you a bowler or batsman or a all-rounder? Please be quick. We don't have, 2, 3 hours of class. I usually take class of 40, 45 minutes. You have to be very quick. A boy pushing a wall. No, that's not the work done because the wall will not move. The wall will not move. अगर वो move नहीं होती है, displace नहीं होती है, so that is not work done, isn't it? Okay, so let's suppose you play cricket and you are a bowler, right? What do? If you are a fast bowler, you take run up and you throw the ball towards the batsman. You are pushing or you are putting force on the ball, and the ball is getting displaced from you to the batsman. So that is work done. Again, when the batsman hits the ball with the bat, again there is also work done. Ball ki displacement hogi, right? Yeah. So very simple examples are there. Okay, now work done by a constant force. How is work defined in science? To understand this, we shall first consider the case when the force is acting in the direction of displacement. Let a constant force F act on the object. Now अभी यहाँ पे एक constant force F is acting on the object. Now what is means by constant force? Constant force यानी कि like force of सेम मैग्नीट्यूड और इक्वल सेम मैग्नीट्यूड मतलब वो चेंज नहीं हो रहा है कांस्टेंट फोर्स ओके सो अ कांस्टेंट फोर्स एफ एक्ट्स ऑन एन ऑब्जेक्ट ये बहुत इंपॉर्टेंट है ओके आप ऐसा नहीं बोल सकते कि फोर्स एफ इज एक्टिंग ऑन एन ऑब्जेक्ट वी हैव टू टेल we have to underline that the force is constant. Let a constant force F acts on the object. Let the object be displaced through a distance s. ठीक है फोर्स f है कांस्टेंट फोर्स f है and the displacement or the distance that is s in the direction of force. डायरेक्शन मतलब जिस डायरेक्शन में फोर्स लग रहा है उसी डायरेक्शन में डिस्प्लेसमेंट हो रही है. Let w be the work done. We define work to be equal to the product of force and displacement. तो वर्क का फॉर्मूला वेरी सिंपल. Work done is equals to force into displacement, where F is a force, S is a displacement. So अगर आप यहाँ पे बात कर रहे हो, so this is object. In this direction, the force is being applied, and this distance S is the displacement of this object. So in this case, the work done will be W. Thus, work done by force acting on an object is equal to the magnitude of the force multiplied by the distance moved in the direction of force. Work has only magnitude and no direction. So work is not okay. You don't have that concept, I guess. So only thing to remember is that work has only magnitude and no direction. उसको direction नहीं होती है. ठीक है. So let us suppose force is 1 Newton and the displacement is 1 meter. So the work done by the force will be 1 Newton meter, or its another unit is joule. So thus 1 joule is the amount of work done on an object when force of 1 Newton displaces it by 1 meter along the line of action of the force. ठीक है तो वर्क डन का समझ या W is equals to F into S. Very good. So look at equation 11.1 carefully. What is the work done by the force on the object is 0? What is the work done by object when the force on the object is 0? What would be the work done when the displacement of the object is 0? Refer to the conditions that are to be satisfied with to say the work is done. So इसका मतलब क्या होता है? Now see, we took an example earlier जिसमें कि मैंने बोला था कि you are pushing a big rock or a mountain. Okay, एक बड़ा रॉक आप पुश करने की कोशिश कर रहे हो, यू आर पुटिंग लॉट ऑफ फोर्स, बट इज देयर एनी डिस्प्लेसमेंट? वो पत्थर हिल रहा है थोड़ा सा भी, वो चट्टान हिल रही है थोड़ी सी भी? नहीं, इट्स नॉट मूविंग एट ऑल, राइट? ऑल्दो देयर इज ह्यूज फोर्स, but there is no displacement. Is there wonder? No wonder, right? Allow me a second. Okay, so you got this? डिस्प्लेसमेंट नहीं होगा तो वर्क भी नहीं है, ठीक है? For work to be done, there has to be displacement. समझ रहे हो? Let us suppose there is some displacement, or yeah, so there is some displacement, but there is no force applied on the object. So in that case, also there will not be any work done. ठीक है? Okay, so let's take the example here. A 5 Newton का force is acting on object. The object is displaced by 2 meters in the direction of force. See, this is again important. कि displacement किस direction में हो रही है? So it is in the direction of force. मतलब जिस direction में force लग रहा है उसी direction में displacement हो रही है, right? Force यहाँ से लग रहा है towards this. So object का जो displacement है वो भी इसी direction में हो रहा है, isn't it? So if the force acts on the object all through displacement, then the work done is 5 Newton multiplied with 2 meter is equals to 10 Newton or 10 joules. ठीक है? अभी आप यहाँ पे भी फाइंड आउट कर सकते हो, 7 into 8, that's it. एक मल्टीप्लीकेशन ही करना है, yeah? Okay, so consider another situation in which force and displacement are in the same direction. A baby pulling a toy car parallel to the ground, as shown in figure 11.4. The baby has exerted a force in the direction of displacement of the car. In this situation, the work done will be equal to the product of force and displacement. In such situations, the work done by the force is taken as positive. ठीक है? अभी ये जो बेबी है, it is applying the force in the direction of displacement. मतलब force इस तरफ लग रहा है, ठीक है? She is pulling it. The baby is pulling the car. That means the force is being applied in this direction and the displacement is also happening in this direction. So that means this is a positive work done. Consider a situation in which an object is moving with a uniform velocity along the particular direction. Now, retarding force F is applied in the opposite direction. That is, the angle between the two directions is 180 degree. Let the object stop after displacement S. In such situation, the work done by the force F is taken as negative and denoted by minus sign. The work done by the force is F into minus S or minus F into S. It is clear from the above discussion that the work done by a force can be either positive or negative. To understand this, let us do the following activity. ठीक है, तो अभी मुझे एक ऐसा एग्जांपल बताओ जिसमें कि फोर्स जो है दैट इज बीइंग अप्लाइड इन ऑपोजिट डायरेक्शन ऑफ द डिस्प्लेसमेंट, मतलब डिस्प्लेसमेंट के ऑपोजिट डायरेक्शन में फोर्स लग रहा है. Can you think of an example like this? Well, I can think. Okay, friction is. Okay, let's not take that complicated example because it will be, very. Uh, it will be very confusing to understand. Let's take a simple example. मैंने क्रिकेट की बात की थी, right? So the batsman has hit the ball. ठीक है? Now, what will be the next step? क्या होगा आगे? Fielders will field it. ठीक है? तो fielders क्या करेंगे? जिस डायरेक्शन से बॉल आ रहा है उसके ऑपोजिट डायरेक्शन से उसे रोकने की कोशिश करेंगे, राइट? सो व्हाट दे आर डूइंग इज They are applying the force in the opposite direction of displacement, isn't it? Ball displace हो रहा है and they will apply force in opposite direction. So that is example of negative that is example of force in opposite direction, isn't it? Very simple example. Yeah. Okay, so okay, we have understood this कि work done जो है that can be either positive or negative, and we have seen the example also. So work done is negative when the force acts opposite to the direction of displacement. Work done is positive when the force is in the direction of displacement. तो जब हम डायरेक्शन की बात कर रहे थे, so it was important because of this. So uh, we have to also calculate whether the work done is positive or negative, right? A potter lifts a luggage of 15 kg from the ground and puts it on the head 1.5 meters above the ground. Calculate the work done by him on the luggage. So mass of the luggage will be 15 kgs and displacement is 1.5 meters. So since we have to use force here, so force is nothing but m into g. तो यहाँ पे g का वैल्यू जो है राउंडेड ऑफ टू 10 लिया है, ठीक है? So it's 10 here, and when we multiply this, we get this as the answer, that is 225 joule of work is done by the porter to lift the luggage. ठीक है? Now the next concept that we are going to learn is energy. Life is impossible without energy. The demand for energy is ever increasing. Where do we get energy from? The sun is the biggest natural source of energy to us. Many of our natural resources or sources are derived from the sun. We can get energy from the nuclei of atom, the interior of earth, and the tides. Can you think of some other sources of energy? ठीक है, अब यहाँ पे जितने सारे सोर्सेस दिए हैं, सो कोई और सोर्स आपको याद आता है जिससे कि हमें एनर्जी मिल सकती है? ओके, कोल, फाइन, पेट्रोल और डीजल, करेक्ट. Yeah, that's what we discussed here, right? Nuclear energy is nuclei of atom. So that is nuclear energy. Yeah, petrol is one, correct. Wind energy is also there. Wind energy, isn't it? Yeah, so the word energy is often used in our daily life, but in science we give it a definite and precise meaning. Let us consider the following examples. When a fast moving cricket ball hits a stationary wicket, the wicket is thrown away. ठीक है, यहाँ पे फिर से एक एग्जांपल आ गया क्रिकेट का. फास्ट बॉलर ने बॉल डाला एंड विकेट, विकेट इन द सेंस कि जो स्टंप्स रहते हैं ना उसे विकेट भी कहते हैं, इफ यू डोंट नो, राइट? तो द विकेट इज थ्रोन अवे. सो वो जो बैट्समैन है वो बोल्ड हो जाता है, द स्टंप्स गो कार्टवेलिंग. Similarly, an object when raised to certain heights gets the capability to do work. You must have seen that when a raised hammer falls on nail placed on the piece of wood, it drives the nail into the wood. We have also observed children winding a toy such as a toy car, and when the toy is placed on the floor, it starts moving. When a balloon is filled with air and we press it, we notice it change in its shape. So as long as we press it gently, it can come back to its original shape. When the force is withdrawn, however, if we press the balloon hard, it can even explode, producing a blasting sound. In all these examples, the objects acquire through different means the capability of doing work. So an object having capability to do work is said to possess energy. Okay. So the object which does not work, the object which does the work loses energy, and the object on which the work is done gains the energy. ठीक है, जो ऑब्जेक्ट वर्क करता है उसका एनर्जी लूज होता है, और जिस ऑब्जेक्ट पे वो वर्क किया जाता है उसे वो एनर्जी गेन होती है. So how does an object with energy to work? How does an object with one energy to work? An object that possesses energy can exert a force on another object. When this happens, energy is transformed from the former to the latter. तो जो जब हम पुश करने की बात करते हैं, सो when a bowler is bowling, that means the bowler is putting some energy on the ball, and the bowler loses some energy and the ball gains some energy. ठीक है. Now the energy possessed by an object is thus measured in terms of its capacity of doing work, and the unit of energy therefore is same as that of work, that is joule. So 1 joule is the energy acquired to do 1 joule of work. Sometimes a larger unit of energy called kilojoule or kj is also equal, or that is equal to 1000 joules. Okay. Now you must have understood what exactly energy is. Now, luckily, the world we live in provides energy in many different forms. The various forms of energy include mechanical energy, potential plus kinetic energy, heat energy, chemical energy, electrical energy, and light energy. So, how do you know that some entities form of energy? Discuss with your friends. तो कैसे मतलब how you will define that this energy is form of, like, this entity is form of energy. So the simple answer to this would be, अगर वो चीज कुछ वर्क करने के काबिल है, or if it can do some work, so then we can say that the entity is form of energy. ठीक है. Now let's learn about James Prescott Joule. So he was an outstanding British physicist. He is best known for his research in electricity and thermodynamics. Among other things, he formulated a law for the heating effect of electric current. He also verified experimentally that the law of conservation of energy and discovered the value of mechanical equivalent of heat. The unit of energy and work called joule is named after him. Okay. So he was the scientist that give scientific meaning to these terms. So first of all, we will learn about kinetic energy, and this will be the last topic for today's class. So let's learn kinetic energy. Take a heavy ball, drop it on the drop it on a thick bed of sand. A wet bed of sand would be better. Drop the ball on the sand from the height of about 25 centimeter. The ball creates a depression. Repeat this activity from the height of 50 centimeter, 1 meter, and 1.5 meter. Ensure that all the depressions are distinctly visible. Mark the depressions to indicate the height from which the ball was dropped. So compare their depths. Which one of them is deepest? बताइए. आप एक बॉल लेते हो that is very heavy ball, या फिर मान लो कि the ball is made up of iron or heavy metal, or uh, whichever heavy object. ठीक है. सो पहले तो हम क्या करते हैं, 25 सेंटीमीटर से वी टेक बेड ऑफ सैंड. बेड ऑफ सैंड यानी कि जो रेत का जो होता है ना, गीली रेत. सो उस पे हमें क्या करना है, पहले तो एक 25 सेंटीमीटर से बॉल गिराना है, वो हेवी वाला. उसके बाद में 50 सेंटीमीटर से, उसके बाद में 1 मीटर से, उसके बाद में 1.5 मीटर से. सो विच ऑफ द इम्प्रेशन और द डिप्रेशन विल बी डीपेस्ट? कब का जो मतलब कब डीपेस्ट रहेगा? जब बॉल 1.5 मीटर से डाला जाएगा. या which one of them will be shallowest? Why? 25 सेंटीमीटर वाला will be shallowest, isn't it? So क्यों हुआ ये? अगर हम सिंपल टर्म्स में इसकी बात करें, तो देयर इज नो इनफ, स्पीड नहीं है इनफ उस बॉल में। जब 25 सेंटीमीटर से हम डाल रहे हैं, तो मतलब जल्दी से वो पहुंच जाएगा जमीन पे, एंड इट विल हैव शैलो डिप्रेशन। लेकिन जैसे ही हम हाइट बढ़ाते हैं, तो क्या होगा? डिप्रेशन ज्यादा होगा। ओके, लेट्स डिस्कस सम अदर एक्टिविटी। तो मान लीजिए कि यू आर जंपिंग फ्रॉम ए बेड। ठीक है, आपका आपका जो बेड है, आप आपके बेड से जमीन पे जंप कर रहे हो। ठीक है, सो ज्यादा से ज्यादा बेड की हाइट जो है वो 1 मीटर रहेगी। ठीक है, आपको कुछ होगा? नहीं होगा, कुछ नहीं होगा, राइट? यू विल बी स्टैंडिंग ऑन योर टोज और योर फुट। ठीक है, नो मान लीजिए यू गेट पावर ऑफ स्पाइडरमैन। ठीक है, you now you have become Spider-Man and you go on 20 story building। 20 मंजिला इमारत पे आप जाते हो, उसके छत पे, and you say I'm a Spider-Man and now I can jump off this building and I will land safely on the street or we can say ground। ठीक है, जैसे ही आप जंप करते हो, आपको पता चलता है कि योर पावर्स हैव वेनिश्ड, आप स्पाइडरमैन नहीं रहे। जंप करने के बाद में आपको पता चलता है, व्हाट विल हैपन? Okay, that will be very harsh to imagine. Let's not discuss this. Why? Because आप ज्यादा हाइट से जंप कर रहे हो, राइट? सो इट विल हैव अ बिगर इम्पैक्ट। आप जब बेड से जंप कर रहे हो, सो इट विल हैव वेरी लेस इम्पैक्ट। देयर इज रिस्क, अगर बेड थोड़ा सा ऊंचा है या फिर आपका फर्श मतलब गीला है, सो आप वहां से भी गिर सकते हो, बट देयर इज वेरी लेस चांस, right? So don't do these activities at home. This was just for discussion. Nobody gets power of Spider-Man and all, okay? It's only good to watch in movies. ठीक है? Okay, so a moving object can do work, an object moving faster can do more work than the identical object moving relatively slow। तो मतलब क्या है कि एक मूविंग ऑब्जेक्ट जो है वो वर्क कर सकता है, जितना फास्ट वो ऑब्जेक्ट मूव करता है उतना ज्यादा वो वर्क कर सकता है। So a moving bullet, blowing wind, a rotating wheel, a speeding stone can do work. How does a bullet pierce the target? How does the wind move the blades of windmill? Objects in motion possess energy. We call this energy as kinetic energy। ठीक है, कौन सी एनर्जी होती है इन सब चीजों में? काइनेटिक एनर्जी। सो व्हेन यू आर जंपिंग फ्रॉम द 20 स्टोरी बिल्डिंग, यू आर गेटिंग मोर एंड मोर काइनेटिक एनर्जी। आप में काइनेटिक, स्पाइडरमैन की तो एनर्जी बिल्कुल नहीं आएगी, बट यू विल हैव काइनेटिक एनर्जी एंड दैट विल आइदर हैव इम्पैक्ट ऑन द ग्राउंड और ऑन यू। ठीक है, so yeah, that's kinetic energy। A falling coconut, a speeding car, a rolling stone, a flying aircraft, flowing water, blowing wind, a running athlete, etc. possesses kinetic energy। In short, kinetic energy is the energy possessed by an object due to its motion। The kinetic energy of an object increases with its speed। तो काइनेटिक एनर्जी क्या है? एक मूविंग ऑब्जेक्ट एनर्जी कैरी करता है, एंड दैट एनर्जी इज कॉल्ड काइनेटिक एनर्जी। एंड व्हेन द स्पीड ऑफ द ऑब्जेक्ट इज मोर, द काइनेटिक एनर्जी इज आल्सो मोर। हाउ मच एनर्जी इज possessed by a moving body by virtue of its motion? By definition, we say that the kinetic energy of a body moving with a certain velocity is equal to the work done on it, make it acquire the velocity। Okay, so before we discuss maths about this kinetic energy and all, do you have any questions? Because I'm going to stop for today. Do you have any questions? I believe not, because we are going very slow, and I believe you must not be having any questions. So if no questions, all of you please put a no in the chat box. I can see from Safir uh, if you don't have any questions. So today's class has ended, students, and I will see you in the next class. Till then, take care and keep studying. So this class has ended and you are free to leave the class. Bye bye.